various reasons. They start us out on these A's. In definition 1, equation 2, both of those have an A in them. Definition 1 has an X in it, and so for that reason they don't use the variable X in defining those slopes of the tangent lines. However, since we're focusing now exclusively on this one, think about this. What this means is the derivative, so we've got the derivative of A is 2A minus 5, whatever A is. Okay, what if I was wanting to find then, let's tack on here this problem. All right, what is the slope of the tangent at A equals 2? What would that be? That'd be, be negative 1, wouldn't it? The slope of the tangent is negative 1. How do I get that? Well, A is 2, so plug that in. I've got the derivative at 2. Plug that in, you got negative 1. The derivative is the slope of the tangent, isn't it? So I'm just plugging in A to be 2. Okay, what about the slope at A equals negative 5? Same thing. The slope's going to be, plug in negative 5. 2 times negative 5 minus 5 be negative 15. Here's my point. I can use this for any A value, or in essence any X value I want. Plug in whatever X value you want, which we're calling the A value, but the slope's varying depending upon what A you choose. In other words, this A, well, it's a variable and it's just like X. So where I'm going with this is this. We're not going to use A lot of the time. Matter of fact, I think after this homework section, the first section, section 2.1, we don't use A for slope of the tangent anyway. We're just going to say the derivative at X, because that's what A is. A is an X value, right? We're just plugging in A is 2 means X is 2. A is negative 5 means X. Yeah, A is just an X value. So we're just going to forego using A and just call it the derivative of X, f prime of X. And that equals, by definition, limit definition, H approaches 0, f of, instead of A now we have X, so it'll be f of X plus H minus f of X over H. Do you see that's the same thing? It's the very same thing. I'm using X, though, instead of using A. A was good for a while, but now we move on to bigger and better things here, okay? Yeah. We're just going to call it the derivative at X, because that's what A is. A is an X value. Okay? So it says find f prime of X for f of X equals 1 over 3 minus X. What should we do? Well, we'll learn different ways, but for now, we're just using the limit definition. Okay. F prime of X is equal to the limit as H approaches 0 of f of X plus H minus f of X over H. Instead of A's, we're using X's. All right. What is f of X plus H in this case? Well, I'm going to plug in my x plus h for x. So that'd be 1 over 3 minus, now it's minus x, so if I'm plugging in x plus h, won't it be minus x minus h? Won't it? Is that right? Then I'm just going to subtract f of x. Well, f of x is 1 minus 3x, so that's what I replace f of x by. And then all that over my h. So that's a nice limit. How do I do it? Well, it's a complex fraction, and the complex fractions we did what? Well, we got a common denominator on top, right? So the limit as h approaches 0, this is all over h, so the first one, I need to make these two denominators kind of come together, right? So I need to multiply this one by 3 minus x on bottom, so I have to do that on the top. And then this one, it's got 3 minus x, so I need to multiply it by the 3 minus x minus h. And that way I'll have a common denominator there on top. What will I have? Well, I'll have 1 times that will be just 3 minus x. Then minus 1 times that would be minus 3 plus x plus h. And then it'll be over 3 minus x minus h, 3 minus x. And then all that's over h. With me on that? Sound okay? All right, now let's see if we can get this figured out here. So that would be the limit as h approaches 0. 3's are out, x's are out. All I have is plus h there. And then 3 minus x minus h times 3 minus x. And then what do we do with the divide by h? Move it up and say it's times 1 over h. That'd be a better way of writing it, because what happens? The h's cancel. Okay? And that'll just leave me the limit as h approaches 0 of 1 over 3 minus x minus h times 3 minus x. Now the h goes to 0. We have no problem, because the bottom does now not go to 0. We're in good shape. Just the h goes to 0, right? And so that'll be the limit as h approaches 0 of 1 over 3 minus x minus 0 over 3 minus x. Just the h is going to 0. So it's just 3. Whoops, it's not the limit anymore, is it? It's just 1 over 3 minus x twice. Or 3 minus x squared. Is that okay? All right. So yeah, it's really, we've done these a couple times now. We're just now calling it f prime. Any problems or concerns? All right. Okay, so what if I asked you to find the derivative of g of t equals the square root of 3t plus 2, and it'll say, may not say, but you will have to use the definition of derivative. The limit definition of derivative, so to speak. What are we looking for here? Well, the derivative is g prime. Yeah, well, I guess it should be pointed out, the definition is in terms of f prime of x. Well, it goes the same for g of t, doesn't it? If I'm trying to find the derivative of g of t, I'm trying to find g prime of t. Instead of f prime of x, I'm finding g prime of t. All right, and so what is g prime of t by the definition of derivative going to be? Well, it's going to be the limit as h approaches 0 of, instead of f of x, I've got g of x, g of t again, so it would be g of t plus h minus g of t over h. Yeah, instead of f of x, I'm changing everything over to g of t's. With me? So instead of f of x's, I've got g of t's. It's all the same, though. Just okay. Just changing letters and things. It's all the same. Okay, so limit, then as h approaches 0, g of t plus h, what's that going to be? Well, I'm going to plug in t plus h for t. So it would be the square root of 3 times t plus h. Let's go ahead and write that as 3t plus 3h plus 2, wouldn't it? Isn't that what t plus h would be plugged in? Square root of 3t plus 3h plus 2. Okay? Minus g of t, what's g of t? 3t plus 2 square rooted. All over h. All right. So here's a nice little limit with square roots in it. What do I do for limits with square roots in them? A lot of times I use the conjugate. I'm going to use the conjugate here, aren't I? I'm going to take this top, so I can't substitute h as 0 because the bottom goes to 0. I'm going to take the top and multiply it by its conjugate. Square root of 3t plus 3h plus 2 plus the square root of 3t plus 2. So change everything. Everything's the same except change it to a plus here, and then same thing on the bottom. Square root of 3t plus 3h plus 2 plus the square root of 3t plus 2. Multiply the top by that, and then multiply the bottom by that. Well, as we know, usually to simplify this, it's just multiply the top out, and nice things happen. What happens when I multiply the conjugates together here on top? Well, I get the square root of 3t times the square root of 3t plus 3h plus 2. Square roots cancel. So I get the 3t plus 3h plus 2 without the square root in it. Now when I multiply this square root by the one on the end and then the middle two, what happens? They cancel out. So I'm not going to write those. You can if you want, but they will cancel out. And then that'll leave me then that times the minus square root of 3t plus 2 times the positive square root of 3t plus 2. Well, that'll make a minus 3t plus 2, but then what about the bottom? Well, the bottom, we're just going to leave it as it is, not going to multiply it out. So it'll be h parentheses 3 square root of 3t plus 3h plus 2 plus square root of 3t plus 2. All right, I'm not going to write all that again because what's going to happen, this is going to become a minus, and this is going to become a minus. So I have minus 3t, and I'll have minus 2. Well, that'll cancel minus 3t's out, 2's, they're out. So all that I have on top is an 3h. Okay, I'm still in there. All right, still in the picture. But what happens then? The h's going to cancel, which takes out the problem, doesn't it? Now, h can go to 0. I can plug in h to be 0, can't I? Because the h in the bottom doesn't cause my denominator to go to 0 any longer. So I get the limit is actually 3, and then I'll have the square root. That'll just be, since h is going to 0, that'll be 0. So that'll just be the square root of 3t plus 2. That'll be the square root of 3t plus 2. So don't I have on the bottom 2 square roots of 3t plus 2? So it's going to be 3 over 2 square root of 3t plus 2. Which is fun. A lot of fun there. But nothing we haven't, well, we've seen stuff like it before already. Really, we're doing the same thing that we did not too long ago, a day or so ago. We're just doing it now, calling it the derivative. It's all the same. So it was a real good reason for doing what we were doing there. Okay? All right. Now, one other, is that okay? Any question or concern? Any step along the way there? All good? Okay. Well, let's try one other one here. How about this one? Find f prime of 3 for f of x equal x cubed minus a. I guess there's a couple ways you can approach it. One way to approach it is just, well, say all I need to do is find f prime of x, and then I've got x is 3. I can just plug in my 3 there. I could go ahead and plug in at 3 at the first, but I would suggest let's just first find f prime of x, and then we can make our substitution off of that. So f prime of x, we got the limit h approaches 0 of f of x plus h minus f of x over h. So that'll be the limit as h approaches 0 of what in this case? You know, we got x plus h for x there, so it'll be x plus h cubed minus 8. Then we'll have minus f of x, so that'll be minus x cubed plus 8. Let's say minus parentheses x cubed minus 8 all over h with me on that, using the definition of derivative. Okay, well, how do we proceed? Probably want to go ahead and cube that out. X plus h cubed. Yeah, that's x plus h 3 times. All right, so that and that's x squared plus xh 2xh plus h squared. Multiply that by x plus h. So that'll be x cubed plus x squared h plus, 2xh times x will be 2x squared h. 2xh times h will be 2xh squared. H squared times x is xh squared. And then h squared h is h cubed. So here's x plus h cubed, clean it up with the like term, so I have limit as h approaches 0. x plus h cubed, we got an x cubed. It's 3x squared h, isn't it? 1x squared h, 2x squared h is 3x squared h. Then we've got 2xh squared and 1xh squared. That's 3xh squared. Like terms there, right? And then h cubed. Okay. All that for x plus h cubed. Then I've got minus 8. Then I've got minus x cubed. And then I have minus 8, so that's plus 8. How's that sound? With me so far? Okay. All right, so that's the limit as h approaches 0. What goes out? Well, the x cubed go out, the 8s go out, and that's about it. However, the 3 that are left have an h in them, so I'm going to factor off an h. So that'll be h parentheses 3x squared plus 3xh plus h squared. So I'm pulling off an h off of those to cancel with the bottom h. And sure enough, now h can go to 0. If h goes to 0, that goes to 0, that goes to 0, so yes, this limit turns out to just be 3x squared. Okay, but that wasn't what we wanted to find. That's f prime of x is 3x squared. I wanted to find f prime of 3. So what is f prime of 3? Well, put in x to be 3 now. If x is 3, f prime of 3 would be 3 times 3 squared, which is 27, isn't it? 27. Is that okay? All right. Part B on this one. That was A. Find the equation of the tangent line at x is 3. Should you do that? Find the equation of the tangent line at x equals 3. Okay. How do I do that? Well, first of all, we're talking about a line, so first of all, what is the slope going to be of this tangent line? Well, isn't the slope going to equal the derivative at 3? Which I just found to be 27. So this one's going to have a slope of 27. Then the tangent line, y equals mx plus b, or however you want to find it. I now know m is 27, so 27x plus b. If I do it this way, I still need to find b. How am I going to find b? Well, I've got an x value. I know x is 3. What's the y value? Well, the y value is, I don't think it's 0. Okay. Yeah, this y value is just the function value at 3. Not the derivative at 3, but the function value at 3. So that goes all the way back to the original function, doesn't it? The function value at 3 would be, what, 27 minus 8? Plug in 3 cubed minus 8, 19. So that y that goes with x is 3 would be 19. Is that okay? It may not give that to you. You just have to go back to the original function. So that's going to be 19 equals, what was that, 81? So it looks like b is going to be about negative 62. So it's y equals, equation of the tangent line is going to be y equals 27x minus 62. Did I do that right?